notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. I am hoping that by the end of September 2024, I will be able to upload and publish these 32 videos on number theory and computation. And then by October, that's next month, the 13 to 15 videos or so on consumer arithmetic. Following month, sets. By the end of December, measurement. Beginning 2025, January, statistics. Then February, algebra. March, relations, functions, and graphs. April, geometry and trigonometry. And then by May, mid-May, vectors and matrices. And that will take care of the whole syllabus. Just a reminder that I have divided section 1 into 32 videos, and they will all be available on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. These 32 videos from section 1 cover the math schoolwork up to the end of Form 3, which is grade 9. That is over a 3-year period from Form 1 to Form 3. All 16 videos on this part of that list have been already published. And now we are here, video 18, section 1, objective 7, part 3, bases 4 and 8. And it is actually video 18 in the series of section 1 videos. So we continue with objective 7. State the value of a digit of a numeral in a given base. And we are to discuss place value and face value in the following bases. 2, we did that already. As a matter of fact, the first one we did was 10. Then we did 2. And now in this video, we will concentrate on 4 and 8. What you see up here is a print screen from the syllabus. As I said, I have divided this objective into 3 videos. First one, base 10. Second one, base 2. And now, third video. We are here. Bases 4 and 8. That is what we will be doing in this video. Place value and face value of numbers in base 4 and base 8. So we now turn our attention to base 4. We will do that first, and then base 8. Place and face values of numbers in base 4. Recall we said that base 10 has 10 digits, 0 to 9. All other base follow a similar pattern. Base 2 has 2 digits, 0 to 1. Base 3, base 4, which is the one we are doing now, has 4 digits, 0, 1, 2, and 3. Notice 4 is not a digit in base 4. Base 5, same pattern. Base 8, which we will do next in this same video, has 8 digits, 0 to 7. Base 16, which we don't have to do. As I said, the base itself is not one of the digit in that base. For example, 8 is not a digit in base 8, and neither is 2 a digit in base 2. This objective from CSEC requires that you know just the place and face values of digits of a numeral in base 2. We finished that. Base 4, we are doing that right now. Base 8, we will get to shortly. Base 10, we finish with that. Base 4. We will set up this grid, but we will not go through the long process we did with base 10 and base 2, because by now you know how that works. So we are setting up this grid for base 4. In this first position here, we will have 1s, that is 4 to the 0 power. In this second position here, we can have up to 3 groups of 4 1s. In this third position here, we could have up to 3 groups of 4 1s. And then in this next position here on the left, we could have up to 3 groups of 4 1s. So let us say you have 2 stars here. That's fine. You can write 2 in this column. If you add 1 more, which I am not going to show, you can add 3. But if you add 1 more, you cannot write 4 here because 4 is not a digit in base 4. So you have to collect all those 4 stars in a group and carry them over on this side here, like that. And if you keep adding stars, eventually you will have a group of 4 stars on here. You could have up to 3 groups. You could have up to 3 groups. So that's the first group. You could have 2 groups. You could have 3 groups. What you cannot have is 4 groups of 4 over here. Cannot have that. When that happens, you group all of those into a new group and put them over on this side, which looks like this. And in this column, you could have up to 3 groups of 4 of 4s. This red group is 1 group. This blue group is 1 group from over here. And in that group, you had 4 stars, 4. So let us say we have 2, we have 3, that is fine. If you were to add a 4th one here, which I am not going to show, you can't do that. If that happens, you have to take all 4 of those and create a new group and bring it over on this side. So now you have 1 yellow group with 4 red groups in it, and each red group has 4 blue groups, and each blue group has 4 stars. So let us say we are at this point. So we are at this point. We have counted this amount of stars. This position here is 1s. This is 4. This is 16 or 4 square. And then over here is 64. That is to say 4 to the 3rd power. The number of stars we have here in base 4 is 2 of 64, and we have 3 groups of 16. We have 1 group of 4, and we have 2 single stars. If we were to write that, we will write it like this: 2, 3, 1, 2, base 4. And that is exactly how we would say it. We will not say 2,312 in base 4, because that 2 is not 1,000, and that 3 is not 100. So you would say 2, 3, 1, 2, base 4. If we were to convert the number of stars in base 4 that we see here into base 10, it will be 2 groups of 64, that is 2 groups of 64, plus 3 groups of 16, that's this 3 group here of that 16 there, and then 1 group of 4, that is to say this 1 group of that 4, and finally 2 single stars. If you add those, you will get 182. And now you can say 182 because we are in base 10. Just to review base 10 to show how it compares or contrasts with base 4, you may recall that this 10 to the 0 is actually the first position here, the ones. And as you go to the left, this index increases by 1. So that's 10 to the 1, 10 to the 2, 10 to the 3, and so forth. When you come over on the right, it will be 1 over 10 to the 1, which makes it 10 to the negative 1. The actual numbers we know it better as is 100 and so on. Those are the positions or the place value on the left of this one. And on the right, to be 1/10 or 10 to the negative 1. And then the next one on the right will be 1/100th or 10 to the negative 2, and so on. We did this already. So if you have a number like 4,507.892, and we consider any one of these digits, let us say this 5 here, that 5, face value is 5, and it is in the hundreds position, which is 10 squared. This 8 here, its face value is 8, and it's in the 1/10th position, or 10 to the negative 1, and so on. Let's compare that with 4. Well, this first position here is 4 to the 0, just like that one up there was 10 to the 0. This second position here is 4 to the 1 power, just like up here it was 10 to 1 power. This third position going to the left is 4 to the second power, 4 squared, just like up here is 10 squared. We did that for base 2. We did it for base 10 2 videos ago. I am just comparing it now. And then this other position here is 4 to the third power, just like this here was 10 to the third power. And if you come on the right here, the right of that 1, over here is 4 to the negative 1, similarly as up here was 10 to the negative 1, and so on. Now the actual number we have here is 1, 4, up here we had 10, this place value is 16, up there we had 100, this one is a quarter, which is 4 to the negative 1, which is 1 over 4, and up here we had 1/10, and so on. So let's take a number in base 4, 1302.123. Pick any digit there. Pick this 3, for example. That 3 is in the 16th position, which is the same as 4 squared. That is its place value, and its face value is exactly what you see there, 3. Remember, this is base 4, so we can't have any digit greater than 3. We could go up to 3. And if you consider this one over here, that 1 face value is 1, but place value is 1/4 or 4 to the negative 1. I think by now you understand how this goes. If we want the decimal equivalent of this base 4 number that we just wrote there, we have 1/64, that is this. We have 3/16, that is 48. Well, we have no 4, no 4. We have 2 1s, that is 2. We have 1/4, which is this. We have 2 1/16, which would be 2 over 16. And we have 3 1/64, or 4 to the negative 3, and that would give us 3/64. If we were to add all of these, 64 plus 48 plus 2 plus a quarter plus 216 plus 3/64, we will get the decimal, the base 10 equivalent of this base 4 number. One final look at base 4. Here is 4 to the 0. That is 1. The actual numbers 1, 4, 16, 64. That's 4 to the third power. 256, 4 to the fourth power, and so on. And then we come on the right here, 4 to the negative 1, which will be a quarter, which means it is the inverse of that, 4 to the negative 1. And then this one is 1/16, which is the inverse of that. So this is 4 squared. This is 4 to the negative 2. And so on. So let's look at an example. 3020321 in base 4. This digit here, we know its face value is 2. What is its place value? Well, we know that this first position here is 4 to the 0 power. Sometimes we forget this is 4 to the 0 power. So that would be 0 power, 1 power, 2 power, 3 power, 4 power, which will be this. Fourth, 1, 2, 3, 4, 5. It is 5 going this way. But when we take into account that 0, it is actually to the 4th power. So 2 times 4 to the 4th power, and we have 512 in base. Let's look at this digit here. 1, 2, 3 going to the left. But remember, the first position is 4 to the 0. So if you count 1, 2, 3, then that would be 4 to the 2nd power. The place value of 3 is 4 to the 2nd power, which is 16. The face value is 3. So what is this digit worth in base 10? 3 times 16, which would give us 48. Let's look at one more example. 3021.23. We will consider this tree here. From this unit position, which is 4 to the 0 power, this will be 4 to the first power, 4 to the second power, 4 to the third power. So this tree is in the position 4 to the third power, that is here. So its position is actually 64, 4, 4, 16, 4, 64. And if you take into account the face value in base 10, it is equivalent to 192. If we consider this 3 here in base 4, now this would be 4 to the negative 1, and this position here would be 4 to the negative 2, which takes us here. So that place value is 1/16, and since we have 3 of it, we will multiply the 1/16 by 3, and we will get 3/16, which is the base 10 equivalent. I think that's enough for base 4. If you find this video useful and interesting, please like and share. That is, like and share. And you may also consider subscribing to this channel. After all, it doesn't cost you anything, and it means a lot to me. We are continuing with base 8. We already know that base 10 has 10 digits, 0 to 9, and all the other bases follow the same pattern. Base 2, we dealt with that before. Base 3 has 3 digits, 0, 1, and 2. Base 4, which is what we just looked at. base 5, which we don't have to consider, but now you know how that works, base 8, which we have to do right now. It has 8 digits, 0 to 7. So 8 is not a digit in base 8. We don't have to do base 16. We already know that 8 is not a digit in base 8. As I said before, all this objective requires you to do is to know the place and face values of digits of numeral in bases 2, 4, 8, which we are doing now, and 10. So base 8. We will not go through the whole system again, but in base 8, this first column on your right here can take up to 7 ones. The next column to the immediate left of that could take up to 7 groups of 8 ones. The next column to the left of that can take up to 7 groups of 8 of 8. And the next column to the left of that could take up to 7 groups of 8 of 8 of 8 ones. By now, this should become very familiar to you. So let us say we were counting stars and we have 6 stars. We can write the 6 there. If you have one more, you can write the digit 7 there. But if you have another one to make 8, you cannot put 8 stars here because base 8 does not have a digit that is 8. You have to take those 8, combine them in one group, and put them over on this side. So now you have one group of 8. If we add some more groups of 8, we now have 1, 2, 3, 4 groups of 8. Remember, this column here could take up to 7 groups of 8. But then if you add some more groups and you get 8, you will have to take all of those and make a larger group over here. And this column could take 7 groups of 8 of 8s. Notice this group has 8 and each little group inside has 8 like what we had over here. So it could take 7 such groups. Let us say we actually have 5 such groups. If we add one more, we will get 6. If we add one more, we will get 7. But then if we add one more and we now have 8, we can't have that. We will have to take all of those, make it into a larger group, and put it over on this side, which looks like this. That yellow group now has 8 red groups, which has 8 blue groups, which has 8 stars in each one. So we have been counting stars and we arrive at this amount of stars. We have 3 groups, that's a face value, of 512. That's the place value. We also have 5 groups, that's a face value of 64. That is the place value. And we have 4 groups of 8. So 4 is a face value, 8 is a place value. And we have 6 single stars. So 6 is a face value, 1 is a place value. So we write that as 3, 5, 4, 6, base 8. Don't say 3,546 because that 3 there is not 1,000 and neither is that 500 and so on. So we say 3, 5, 4, 6, base 8. If we were to carry that base 8 number to see how many stars we actually have in the more familiar base 10 system, we will multiply the 3 by the 512. That's the total amount of stars we have here. And then we would add that to this 5 times the 64 face value, place value. And after that, we will add to 4 times 8, and then finally add the 6, and we will get 1,894. And yes, now we can say 1,894 because we are in base 10. Well, we have seen this base 10 already. I'm not going over that again. I'm just putting it here to compare the base 8. So with base 8, now this is what happens. This position here is 8 to the 0, just like that position up there is 8 to the 10, and so on, 8 to the 4th power, 10 to the 4th power. Over here, it would be 8 to the negative 1. Up here, it was 10 to the negative 1. So we follow the same system, the same pattern. So if we were to convert that into more understandable numbers, this 8 to the 0 is 1. All base, the unit position is whatever that base is to the 0. And that always works out to be 1. Then you go to the left here, 8 to the 1st power, which is 8. Then next position on the left, 8 to the 2nd power, which is 64. That is its place value. And so on. On to the right, it will be 8 to the negative 1 power, which is 1/8. And we can skip that. 8 to the negative 3 power, which is 1/52. Notice this 8 here, and here it is 1/8. This 64 here, and here it is 1/64, and so forth. So let's consider this base 8 number, 7352.573. Write it in here. Let's consider this 7. Its face value is 7. Its place value is 512, which is the same as 8 to the 3rd power. This 5 here, its face value is 5. Its place value is 8, which is the same as 8 to the 1st power. And this 7 here, its face value is 7. Its place value is 8 to the negative 2, which is 1/64. If we want to convert this base 8 number to base 10, since we have 7 in this position, we will multiply the 7 by that, and we get 2,584. This is actually now base 10. We do the same thing with the 3, multiply that by 64, and we get 192. 5 times 8 would give us 40. 2 there. 5 times 1, 8 will give us 5, 8, and so on. And then we add them up. We add that to this, to this, to this, to that, to that. And whatever we get, that is the base 10 equivalent. So one final look at base 8. This is 8 to the 0. This is 8 to the 1st power, and so on. Over here, 8 to the negative 1, and so on. So the actual numbers that we are familiar with in base 10 is 1, 8, 64, 512, that's 8 multiplied by 8 multiplied by 8, and we could go on like that. Eventually, 8 to the 12th power, we get this extremely large number, that's base 10, and 8 to the negative 1, like this, and so on. So let's look at this example. 375 base 8. Now remember, this is 8 to the 0, 8 to the 1st power, 8 to the 2nd power. So if we consider this 3, it would be 8 to the 2nd power, which would be here. So the place value is 64, 8 to the 2nd power. The face value is 3. If we want to know the actual value, we multiply 3 by 8 squared, and we get 192, and that is the base 10 equivalent. If we consider the 7, this will be 8 to the 1st power, which will take us here. And so the face value is 7, the place value is 8, the base 10 equivalent of that is 7 times 8. We will look at one more. Consider this 0 here. We are still in base 8, which is about the same place as that one was just now. And so we know that that would be in the 8th position. So we get 0 is the face value times the place value, and we get 0. Finally, this 3, what is its face value? 3. What is its place value? Well, this here will be 1/8, or 8 to the negative 1, and this will be 8 to the negative 2, which is this position here, and we have 3 of those, so we multiply the face value by the place value to get the decimal base 10 equivalent. So 3 times 8 to the negative 2, and we get 3/64 in base 10. Okay, finally, how well did you do? 259 in base 10. This 2 here, that is to say, this 2 here, what is its place value? Well, that one will be 10 to the 0, 10 to the first, 10 to the second. So that will be 100, 10 times 10, 100. Its face value is, of course, 2. This next one here, this is base 8. We want to consider this 0 here. Well, that will be 8 to the negative 1. So it will be 1/8. Its face value is 0. Next one, this is now base 4, and we are considering the 3. So that will be 4 to the 0, 4 to the first, 4 to the second. So that would be 4, 4, 16. So the place value is 16, and the face value, of course, is 3. This is base 2. Now we are considering the one on the far left, which is this. So let's go again. This is 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, because it's base 2. So 2, 2 is 4, 2 is 8, 2 is 16. So it's in the 16th position, and its face value is 1. Next number, 4, 6, 5, 3, base 8, and we want to consider the 6. This 6 here, this 6 here. So this 3 is in the 8 to the 0 position, this 5 is in the 8 to the first position, this 6 is in the position of 8 to the second. So that will be 8 squared. So 8 will give us 64. So its place value is 64, and its face value is 6. Then we look at this other number in base 4, and we are looking at the 3, that is this 3, way out here on the left. So this 0 is in 4 to the 0 position. This 2 is 4 to the first position. This 1 is 4 to the second position. And this 3 is 4 to the third position. So it's 4 times 4 times 4. So we get 4, 4, 16, 4, 64. That is its place value, and its face value is 3. And finally, 2, we're looking at the one between the zeros, that is this one here. What is its place value? So remember, this first one here is 2 to the 0 power. The next one is 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power. So 2, 2 is 4, 2 is 8, 2 is 16. So its place value is 16, and of course its face value is 1. Now, these same principles apply to all bases. So we have completed all the 4 bases in this objective. We can state the place value and the face value of any digit in base 2, base 4, base 8, and base 10. And that brings us to the end of video 3, objective 7 of section 1.